Good afternoon, Year 13. It's Mr. Punxsutawn here. Hope you're all well. And this is my attempt at Key Assessment 3. So the first question is a multiple choice question, and it asks you to say which bit's the sarcomere, okay? Now, if you know the answer, then that makes life easier, obviously. But I'm going to show you how you might be able to take other ones away so that you're left with the right answer. So A here, okay, that's just showing you this layer here, which is just showing myosin. All right, now from my GCSE days, I think that's the H zone. So then we got to B, and again, B is just showing you a layer where there's just actin in, okay? And again, from my GCSE days, I think that's called the I band. And then we've got D. Now, D shows you a part where you've got the myosin and the actin overlapping. And again, GCSE A band. So these are terms that you've not come across in A-level anyway. And I could understand if you'd have just maybe thought, well, that's actin and that's myosin and that's maybe both. But it still leaves C. And C is the sarcomere, and this is the whole sarcomere, okay? So there's the first one, C. Okay, as I said in my PowerPoint yesterday, this question is wrong. And my phone is recording this, so I haven't got a calculator. So I'll show you how to set it up, and then you can come up with the answer. All right? Now, you need a ruler, and they're asking you, calculate the magnification of this electron micrograph. They're giving you that arrow there, and they're saying that is 2 micrometers. So if I measure that in real time, sorry, excuse my eyes, I'm just going to take that off. Okay, so I've got that as 3.4 centimetres. Now, centimetres are absolutely useless, okay? So I'm going to turn that into millimetres, so 34 millimetres. Now, we've got a micrometre thing going on here, all right? So I want to turn either that into millimetres or that into micrometres. And I think it's probably easier to do that into micrometres, okay? So that equals 34,000, because you've got 1,000 micrometres in a millimetre. Okay, 34,000 micrometres. And then we're going to look at the magnification. Okay, so using our equation, all right, 34,000, so 34,000 over 2 is going to give us our magnification, which comes out at about 17,500, I think. So you didn't even need a calculator. That's your answer there, okay? Which is wrong on the mark scheme, partly because of the measurement, but also I think they've got it wrong anyway. So there you go. If I am wrong, please come back to me and tell me. I'd love to hear from you. So then we've got the number of myofibrils in the electron micrograph. All right. So myofibril is effectively a kind of a bundle of muscle fibers, really. And you can see here that we've got 1, 2, 3. Okay, now even if you counted this across, all right, and you looked at sarcomeres and you got this wrong, 1, 2, 3, and starting to get a 4th, well, there's not 4 in there anyway, so we're looking at the answer being 3 there, which is the answer. 1, 2, 3. Turn over. So the electron micrograph shows myofibers in a relaxed muscle. Explain how the appearance of this myofibril changes when the muscle contracts. So we're looking at contracts and we're looking at explain. As soon as I see explain, I'm thinking I need to have some biology in there. I need to have some understanding, all right? Someone that does A-level biology could answer this question. Someone that doesn't couldn't, okay? Now, if we go back to our thing, we want to contract, all right? We want to contract this sarcomere, basically, okay? Now, if the muscle contracts, all right, these bits are going to move in this way, all right? So our actin are going to move in across the the actin are going to move in across the myosin, okay? They're going to slide across like that. So the size of the sarcomere, i.e. the size of C, is going to decrease, okay? So the sarcomere is going to get shorter. But, and this is key to this, is that the myosin length and the actin length in themselves don't change length at all. And effectively that squeezes together. So they're not changing length, the actin is just sliding across the myosin. Okay, and as you'll see from the answer, all right, so the two things that you need to say there is the idea that the actin and the myosin are the same length. And last but not least, okay, the sarcomere shortens, the Z lines are these things here. The Z lines move close together, you're allowed as well. All right, or just the idea of them sliding across each other. But that word explain is important. Apologies for the singing in the background. Right, last but not least, okay. Another question. Muscle tissue contains fast and slow twitch fibres. This is the stuff that you've just learnt. And to know this, you're going to have to know the difference between those two things. You're going to have to know the difference between those two fibres. You've then got showing a percentage of the fibres in each of those people. Okay, and it's saying explain again, so I need some bio. All right, which person has muscles that are resistant to fatigue? Okay, now as soon as you see fatigue, you should be thinking anaerobic respiration and lactic acid. So that's what my thinking is here. Now the first thing is it's saying explain which person. So I'm going to name which person has got that. So it's person B, and the reason for that is that they've got lots of slow twitch muscle fibres, all right? Or certainly more slow twitch than A. So that's why that's in place. Apologies at the moment, I'm babysitting two children, which is why I keep stopping. So now we need to get this explained bit. So why is it that having more slow twitch muscle fibres than fast twitch muscle fibres is going to make us resistant to fatigue? And this is where our knowledge of this comes along. And this is where that table that I got you to have a look at in the last lesson comes in. Okay, so our slow twitch, they're all about anaerobic respiration. And because of that, they're going to have more mitochondria. Now notice how I am being comparative. Okay, and that's really important because we're looking at the difference between two people. So you've got to be comparative. All right, the second thing going on here is the idea that we can talk about capillaries. And that gives you oxygen. And we can talk about the idea of myoglobin as well. Okay, now myoglobin is effectively the muscle version of hemoglobin. It has a much higher affinity for oxygen and is able to keep a lot more oxygen in it than hemoglobin, for instance. And slow twitch muscle fibres will have a lot more of that. And then at the end, because you're kind of answering the question, we're talking about fatigue. If we're doing our underlining, we're going to say something about fatigue. Therefore, there is a lot less build-up of lactate, okay, in the blood because we haven't got as much anaerobic respiration going on. So there are the marking points for that question. Hopefully you can see how I've gone about that question. All right, and there you go. You've got the mark scheme. You've got the question. So keep going. Okay. Have a look at what you've got. Do your green sheets, and I'll speak to you again soon. Bye bye.